Hello, everyone. Welcome back to Sort Singh Diaries and Merry Christmas. So, in this video, we are going to design a very interesting solution to a very interesting problem. Okay, so we are going to design a flow or a pipeline which will create automatic chapters for the YouTube videos. Okay, and we will use AWS services extensively for each component of our design, and we will also use an AI model for a specific purpose. So, do watch this video to the end. Okay, you'll learn a lot of things, and I'm sure it will be very fun. So, let me explain the problem statement to you guys. So, those who don't understand what is a YouTube chapter, let's go and check it out. So as you see on the screen, I have a YouTube video opened, and you can see we have listed, or YouTube has listed all the chapters of that particular video, right? So what it means is that YouTube categorizes each section or the logical section of the YouTube videos into timestamps, right? So for example, in the for the first 1 minute, right, I just keep on explaining. I mean, just a welcome. Then from the first minute and fifth second, the graph basic starts. I hope you get what chapters mean, right? So the problem that we are going to solve today is how we can actually take this YouTube video as an input, right, and convert or create chapters for that video. We'll basically design a pipeline that is well scaled, okay, and will handle all kind of requests like this, right, in a very scalable and maintainable manner. We'll design each component separately using AWS services. So think of it like more of a backend data processing design that we'll create, okay, and you'll also see how we'll use AI to solve a very specific tough part of the problem, right? So it's a very interesting design that I want to share with you guys. So let's go into it. So let's firstly think like how will we design the entire solution, right? So think of the use case that as a user, I want that I need a user interface. I go and paste the YouTube video URL into that input box in the UI, right? And after that, what I want to do is that I want to wait until all the chapters gets created and I get notified somehow whenever it gets created, right? So we need to build that whole flow or the design the data pipeline for our users, right, who want to do this. So what we will do is think of this particular section that I'm sharing my screen, right? So you can see that we have a client or a browser sitting over here. Okay. Oops. Okay. And so think of it like here is our UI, right? So here is where our UI for inputting that YouTube URL exists, right? So the YouTube URL could be anything like this, right? Let's go and take one particular YouTube video from my channel. And so a sample YouTube video could be this, right? And we have this YouTube URL over here, right? So think of it that the user will come and take this URL and will just imagine like he wants to just share, he'll just copy this entire URL, right? He can just copy this entire URL for the video which he wants the automatic chapters to be created, right? So he will just copy and paste it on his UI, right? From here, the entire flow will kickstart, and that's what we will discuss today. Okay, so what happens is that think of it of the very basic flow that we want to design, right? So I'll just write over here. So user inputs the YouTube URL, video URL, right? So this is how the flow starts, and then the next flow is oops, okay. So the next flow is that the the video should somehow so how will we really know the context of what the video contains, right? Because that is very very important to actually breaking it down into logical components, right? So there are some assumptions that we will do, right? So because we will at some point of time in this design we will use LLM, right? And we will have to assume that our all videos are in English language, right? So this is the thing that is one assumption that we have to base our design upon, right? That whatever language the guy is speaking is English in the entire video, right? And we will see, right, how it goes. So the main thing is that here we need the entire speech, right, as a text, whatever is being said in the video, because that's what is gonna uh, really matter for dividing the entire video into logical chapters, right? So now what we need to do is get the entire content of the video speech as text, right? So think of it that we want to really generate something as an output, which has a timestamp and the chapter title or a short chapter, right? For example, introduction, then second is basics of a topic, and then we go into some live code. These are some logical breakdowns of the video, right? But the second step is that we go and get the entire content of the video uh, as text, right? Whatever is being said, it's been the speech to text. Okay, so and we also need the time codings. It's very important that if you just convert a video into text, it's not enough. We need to know that at what point and at what timestamp which word is being spoken, right? And we'll use a particular AWS service for it, which is very interesting. We'll talk about it. So once you have everything as a text, right, we call it as a transcript, okay, in this concept, right? So once we have the transcript of the video, right, what we need to do is to do any perform any cleanups on the transcripts. I'll come to that what I mean. For example, in a particular YouTube video, there will be a lot of unnecessary words which are not important for the chapters, like hey, or any kind of. I hope you get, but there are some words or some things which does not really matter, and we want to clean up things, right? And there is one more thing that I've come across. Okay, so do any cleanups or processing over the transcript that is needed, right? And then comes the most interesting step is that we will construct a prompt, right? Construct a prompt for AI or LLM model, right? And what we'll say our LLM model, or in this context, we'll ask Claude to do it. Is that, hey, take this prompt. The prompt is one part that I'll come into it. So the prompt will be like, hey, take this transcript, okay, which is just think about it like it is like the entire transcript of the video. You just take this as input, and you also have this time coding information of each word, okay, that has been spoken in the video. That is the output of the AWS Transcribe service. We'll come to that. Just take this entire input, and you now decide where the logical breakdowns you need to make for declaring a section as chapters, right? I'll come to that while we are talking about the design or the component itself deeply, right? So that's the moment when you will get this particularly. But think about it that you will send the information of word map to a timestamp and ask LLM to really break down or give us all the chapters, right? So we'll construct the prompt, okay, and ask LLM for the chapters data, right? And it really makes sense. I'll come to it, why and how we will do it, right? So once we have the chapters data, then it's done, right? You just store this entire data somewhere, and then the next step is to really go and update the description of the YouTube video, right? Because how YouTube renders the chapter metadata, right? You just think about it that topological sort. So here it is, right? If you see the description of my video, I have these chapters written like this, right? This is a manual chapter creation. I just go, and it's a really tedious task to go hover around timestamps, find in what segment I'm speaking what, right? And this is what we'll automate. So once the chapter data is created by our design or our flow, we'll just go and call a YouTube data API to update the description with this data, and the chapters will be rendered. So this is what we are gonna do. It might not be too overwhelming, but let's go and work on the design, and then it will be very, very clear, right? So here we are, right? So think about that. The user will just come on the browser, paste the YouTube video URL, and he will make an API call to trigger the workflow of this entire thing, right? So think about it that from here, we have to make a call to an API gateway. As I said, this will extensively use a lot of AWS services to design, okay? And this is what we'll do in this video, right? So this is our API gateway, okay? And what this API gateway is, so think like whatever backend services or AWS services like Lambda or Glue job. I'll come to that specifics. So think of this entire video as a starter to get you started on AWS services as well. So from here, once you watch this entire video, pick any component and learn it in depth, right? So the browser will make a call to API gateway, okay? And this API gateway routes the request to any individual component that I'll come towards it. So this API gateway will make a request, okay, which will trigger. So right now, what do I have really in this input? I have the video URL, right? So that's the YouTube video URL, which I want to really create the automatic chapters for, right? So once I pass this video URL in a request to the API gateway, API gateway is really like a wall for the front end. You can really create any routes, right? In the API gateway, create any API resources and just call the backend services from here. And why is it necessary? Is because here is the place which really is like a guard for your entire backend services that exist, or the backend pipeline that will exist over here, right? API gateway, you can configure rate limiting, you can even configure extra firewalls or authentication. You can also cache the responses of certain APIs, and that's why this is a very good norm to have a wall or API gateway. It is technically just a service, right, which routes request to another AWS service in this context, right? So think about this, that this API gateway is going to do something, right? And it will, in this case, trigger the entire flow of chapter creation, right? And in this context, we will use another AWS service that is called as Lambda function, right? So let's search Lambda. Here is it. So what this Lambda function is really doing is very interesting, right? So it will just go and invoke a cron job, and in AWS context we call the cron jobs as AWS glue jobs, right? So I'll come to that. Just think of this Lambda. We can name this Lambda function, to be honest, and let's call this as YouTube data processing API, right, which we have exposed from the API gateway. And this Lambda can be called as video upload trigger Lambda, right? We can just name it. So video upload trigger Lambda. So as I said, that just with the URL, you are not going to be able to do anything, right? We need the entire video, that is the entire MP4 file or whatever it is, right? And we need to really process the speech and text that is being said. So you need the entire video. The URL is not enough. So this is what the Lambda will do. Lambda will trigger a job that will download the video from this video URL, and we'll see how. So the next thing, as I said, is we'll use a glue job. And why we are using these resources is very interesting, right? So when you'll go and read about lambdas are just like a code which gets executed on a happening of a certain event, right? And here the event is that a browser sent like the user wants to like create chapters for it. He makes an API request that sends another request to the Lambda. Okay, and this Lambda invocation is like very important because and advantageous as well, because you don't need to manage your own servers. With Lambda, all the auto scaling and management is done by the provider, that is Amazon or AWS, right? So you just trigger the Lambda, forget about it. You just pay upon how much the Lambda is scaling or how much it is being used. You don't need to manage or manually scale anything. It will, so think like every new request to the API gateway will trigger a new Lambda invocation, and all the resources to manage that invocation is managed by AWS, not by you. So that's what is the advantage of Lambda. It's just like we call it a serverless compute because you don't manage the servers yourself. AWS does it. So that's how it is. This is the advantage of Lambda. If there is a very small thing that you want to do, and there's one caveat though, Lambdas come with a timeout of 15 minutes. So if you want to do a thing which takes more than 15 minutes, then you have to not use Lambda, because Lambda will just time out. That's the maximum timeout, I believe. I'll have to check, but I remember that it's 15 minutes. Secondly, the memory constraints are also there. So the RAM or the memory is, I think, limited to 10 GB, if I'm not wrong. And the temporary disk storage that you want to use is also not that much. Okay, so that's one thing where you need to know the limitation of Lambda, and that is why I'm not downloading the video in the Lambda. So Lambda is like you just write a code, maybe Python, right? And that will get executed. And once it's done, the server is down and you are just gone, right? Until the next invocation comes, and again the Lambda function will get invoked, right? So here is some code, but in this Lambda we will not download the video. Okay, we'll trigger another glue job to download, because downloading can maybe take more than 50 minutes. We never know, right? If a user comes and downloads a video of like 3 hours, right, or wants to, who knows, like, right? We need to think about those users as well who want to create chapters for very long videos, right? So you don't want to download the entire video in the Lambda context. So what we do is we use a glue job to really do it. Yes. So from here, what Lambda will do is that it will trigger AWS glue job. It's like a cron job, and this is more suitable for the tasks that take more time, right? So as I told you, the tasks that need some lot of processing time, and also and by the way, glue job has a lot of advantages. It actually runs your job in a very distributed environment using Apache Spark, right? So think about that you need to parse or process a million rows. So it is a big data technology that is Spark. It internally uses Apache Spark, and it will distribute the load over multiple distributed workers or a cluster of nodes, right? And all the results will be clubbed, and then it will be returned to you. And you can really think the power of this, right? It manages the entire distributed processing for you. So that is the AWS Glue offering from Amazon, right? So AWS Glue will take this entire job of downloading the video from the YouTube server, and it will do something, right? So we will name this. Let's do one thing. We can name this as, I noted the names over here, but okay, wait a second. Yeah, so I had named this download YouTube video glue job. Simple. So download YouTube video glue, right? So this is the name of this glue job, and it has a simple task of just downloading the video using the YouTube URL. Okay, and we'll see how it does, but it's like a Python library that will help us do so. So in AWS Glue, it means that you can write a Python code, right, and that will get executed as a cron job or a glue job, right? So this is pretty much it with this, and all the result, that is the MP4 file that will uh, be the output, right? So we need to store this video, right, so that you can later on start the processing of the chapter creation, right? So we need to store it in the S3 bucket, and I think this is the most popular one, but this will help you store the large files, large MP4 files. I mean the video files, right? Whatever gets downloaded. Okay. So this, all right. So till here, we know that we are just storing the video to the Amazon S3, right? And as you can see, the Lambda is triggering the download YouTube video glue. It downloads the video, uploads to S3, right? Or just creates an entry in the S3 for that entire video file. From there, a new flow has to be triggered, which generates the transcript of the video, and we'll come to that. So what we can do is, so you also notice that this Lambda is pretty much just invoking another service or another job, which actually downloads. So here is the point where you need to understand that you can perform some kind of validations, whether the URL that was entered is, so you can do it on the client side, but there are certain checks that you can also keep on Lambda, that whether the YouTube video URL was correctly given, right? And you can also log few things, that this is where the user wants to like create chapters for this particular URL, right? Probably also do any kind of validation stuff, right? So but the glue is invoked only when we know that, okay, this video URL is safe to be like triggered for download, and this glue job is like totally modular and only perform the job of downloading it, right? It might take even an hour, or I don't know how much time if the video is too long. So we'll let glue do its job, right? So now once the video is stored, we go and trigger we can set up that whenever a new file is created in a particular path, we generate a S3 event, right? So this is how most of the flow is created from the S3. We use a S3 event that triggers another Lambda and starts another process, right? So you cannot actually start directly a glue job via S3 event. So you already or always use a Lambda as an intermediary which triggers the downstream jobs. So now what we'll do, we'll use Lambda, which will trigger the transcript, or you can just say it like this, that video transcript trigger, and I'll show you what the output of the transcription looks like, so that you can like relate to what is going on over here, right? So the video transcript trigger Lambda will trigger the glue job, right? And this glue job has the job of actually transcribing the video using AWS Transcribe, right? So let's go and use it. So I know that this is, the diagram will get bigger, but it's really a modular and a scalable way to do things with a very clear separation of concerns. You can handle errors, logging, and monitoring at each of the component, and really make it a well like architected data pipeline, right? So the third thing that we need to do. not the third thing, probably the nth thing. But you think about it, where was I? So we start the transcription by the glue job, and glue job will use the AWS transcribe. Does it even have? Yeah, I think it has this diagram for it. So what it will do is it will trigger the AWS, or it will. So what context it is that uh, you can actually start a AWS transcribe job, okay, over a video, right? Over a video URL which is stored over the S3. So on that video, AWS transcribe will generate the text, whatever is being spoken in the video. And for the simplicity of our scope, right, and our scope, we just wanted the entire video to be in English, right? And I'll come to that why I do that. So it will use AWS Transcribe, and it will convert the entire video. So you know that this trigger will have the S3 video URL, right, and video file URL. So I hope you understand that here is just the YouTube video URL, but this is the actual URL of the file that is being stored, right? That is the MP4 file which has been downloaded and stored. So we pass this URL obviously to the glue job so that it can pass it to the AWS transcribe. And there is a particular way we call AWS transcribe, which you will see when you will go to the code of this entire and each component, which is again a task, right? So we go call the AWS transcribe to, hey, take this entire video, right, from me, and you give me the time coded words at which timestamp where that word was spoken, right? And I'll show you how the response of that particular thing looks like, right? Okay, so as you guys can see, I'm sharing you one sample output that AWS Transcribe gives you, right? So the entire transcript could be, hello, welcome to the AWS Transcribe demo. I mean, this is something that is being spoken in that video, right? So as I said, it will take the entire video file and give you this kind of text that is being spoken in the video. So here is the transcript, the entire transcript. But what is more meaningful is the second attribute, that is items. In this output, we see that we have a start and end time and the word that is being spoken in that particular time frame. So it is a word to a timestamp information that is being given in this entire output. So you see there is a content called as hello, and it has said that with 99.8% confidence that this word is being spoken is hello, right? This is for this confidence. Okay. So hello, welcome to the AWS. So this is word by word separation and timestamp. But as you know that this is not the chapters, right? Chapters is more like in from this to this time, the introduction is there, right? It is more logical and semantic breakdown of the entire text, which we'll see, right? So right now we just have a word to timestamp mapping, which AWS Transcribe has helped us with. So we'll go and now continue our design, right? So as we know that this will return me that whole JSON, right? This AWS Transcribe, and I need to really store this output somewhere. So again, we will go and use another S3 bucket, right, to really store the transcription output. And we can really name something, but it's fine. For now, we'll just say the purpose, store transcription result. And it is actually JSON files. As I showed you, it outputs a JSON, right? So we just go and store it over here in the S3. Okay. So here we are where we have a word to timestamp mapping for one video, right? And before I go and explain you the further flow, just understand that at every step where you are storing the data, okay, you must understand that at later point of time, you might need to refer that data as well, right? So it's important that you store the data properly, right? Because the system is going to be used by millions of requests, and the S3 bucket will have millions of entries. So how do you know like which entry corresponds to which video URL? So you'll use video ID as a path in the S3 file, right? So that video ID, as I showed you, is a part of that link, okay, that YouTube video link that the client or the browser provides us. And we'll just take that video ID and store it as a path in various places in our S3 path so that later on we can refer it. Secondly, the other important fact is that why this is necessary is because let's say the user goes and regenerates the caption at some moment, right? And then the same path would be overwritten. It's very important to maintain the consistency of the results. And the second thing that we want to do is video ID has to be the unique identifier of whatever we are storing. And once we have a partition in the S3, you can probably use that data properly. I mean, I don't want to go into that side, but you can do more analytics efficiently, okay, if you really store the data properly. You can have a timestamp path as a thing, as a placeholder, as a partition in the S3 path, but it's up to you. I think video ID does the job as of now. So this is the flow where we have a raw transcription result, right? So I'll also mention a raw. Okay, so from here, what can happen, right? As I told you that we need to process this transcription and then only we will give it to LLM, right? So as you know, AWS provides you bedrock, right? So if you don't know, let's just read about it quickly. So it's like you are using AWS service to go and ask, query anything, and it will internally use the AI models to give you the answers, right? So it's a fully managed service that offers a choice of high performing foundation models, right? So you can even use Claude because it's Amazon acquired, and internally you can actually choose which model to use, right? Or you can directly integrate with Claude, but given we are doing everything in AWS ecosystem, it's good to just integrate with AWS Bedrock and it will give you the best results, right? So I'll come to that, but what next has to be done is pretty interesting. Okay, so as we see now, what we'll do is we'll trigger Lambda, okay, again, which will trigger the invocation of the glue job. Okay, so this Lambda, we can just call it as chapter generation trigger Lambda. Okay. Uh, See, if you can really find and see that you can skip any lambdas which are just triggering, it's good. But as of now, what I know is that it's not really, there's no method to actually go and trigger the glue job directly from the S3. So you have to always keep a lambda that goes and invokes those downstream jobs, right? So now it will do something called as starting the chapter generation glue job, right? So this is where the main thing happens, where we construct the prompt, right, and also ask the LLM, right, that hey, just tell me the correct chapters, right? So let's see what will happen. So this is only glue job now, and we'll copy this. Okay, now what can happen over here is very interesting. So this glue job is going to do a lot of stuff. It will construct a proper prompt for you guys. So what could be the prompt, right? So the prompt could be that, so as you just like think that you are asking LLM, ChatGPT or Claude, you just go to the input and say that hey, you are gonna transcribe the entire, I mean, you're gonna create the YouTube uh, chapters for my video, okay, and I'm giving you a raw transcription result that I had produced in the S3, and you have to also tell the context that okay, this transcribed result is a JSON file. More clear and concise you are, the better result you'll get. That hey, this is the JSON, and this entire transcription contains the word and timestamp information as you see in this key, right? Now you take this information and create the YouTube chapters for me. The chapter should look like there's a timestamp and the entire uh, title for the chapter, right? And how you are going to decide where the chapter starts and ends is via your reasoning, and by hearing, I mean, and by seeing the text like moving on, right? In the video, a lot of times people will use these words like, okay, let's move on. Okay, the next topic is going on to. So based on these similar words, I'm giving a big prompt to LLM. Okay, just note this. So based on these words, you go and segregate the chapters, right? You have the timestamp and word information already, right? From the here, you curate a chapter title, right? Based on these phrases like going on, moving on, next topic is, all these phrases you just give to LLM. So this is a little bit big prompt, but it will help you get the right answers, right? So you construct the prompt and give it to the uh, so here is where you can just keep that hard-coded prompt somewhere and use it in the AWS glue and trigger the bedrock. Does it have the bedrock, or I'll just use the square for now, okay, to denote that it is AI model. Okay, so this is my AI model, which will like mostly a LLM model. And as we know that LLMs are trained on a lot of texts, and that is why I want that the scope of the entire problem is in English text, right? So only English text has been spoken in the video, and we will go and call our AI model through their API. So Claude has exposed a lot of APIs. AWS Bedrock. Bedrock is a solution, right, which you can do. You go and prompt it. Okay. So whatever this will give you as a result, you will just store it in another S3 bucket. Okay. All right. So this gives you the response. And from here, you'll just go and put it in S3 bucket as a JSON file. And that output chapters will something look like, as I showed you guys, that it will be something like this 00, something like intro. And then, for example, the another timestamp and another chapter title, right? And somehow you can just define a JSON, and that also you can give it in the prompt only, that okay, this is how I want my output JSON to look like. Okay. So from there is a very interesting part that you guys will have to do, and that is uh, calling the YouTube API to append this chapter's data into the YouTube description, and that's it. That's where your flow will actually end, right? So I know this is slightly overwhelming, and we are only talking about the design part. But if you guys need the code for the individual components, also let me know for this as well, and I'll create a separate video for it because this is going on for long, right? So if I summarize this entire thing for you guys, you'll see that the user puts on a video, YouTube video URL, right, and click submits, and that hits the API request. Okay, that API request goes to the API gateway, and that API gateway triggers a Lambda, which will trigger another glue job for downloading that YouTube video using that URL. And there are Python modules and libraries to download YouTube video. It's I think called PyTube, right, where you get these libraries and you can. But yeah, more low-level code when you will write for the individual components you'll get, but it's not a lot of code for these glue jobs because it's just downloading the video. That is why I have segregated the models. This is one possible solution. There are multiple others as well, but this is just one viable solution that actually scales well. So you go, this glue job will download that file, and that file will be written to the S3. That S3 triggers S3 event, as you see, and triggers the transcription of the video. So the video transcript trigger Lambda will now trigger its downstream AWS glue job, which will actually go and call AWS Transcribe, right? And it will, and the AWS Transcribe will actually write. And to be honest, like you can also skip the Lambda over here. I mean, the glue job over here, you can also do this thing from Lambda directly. I mean, I believe this can be done. Okay, so yeah, this is where you can reiterate and see what works best, right? So video transcript trigger Lambda can go and directly call the AWS Transcribe, because here we are not taking a lot of time. This Lambda is not meant to run for 50 minutes because it's just calling the transcribe service and forgetting everything, right? That hey, you go transcribe the video, right? And whatever text or the JSON that you generate, you just store it in Amazon S3. So from this S3, we can trigger another Lambda called as chapter generation trigger Lambda, which will go and trigger the glue job, which will construct the prompt, right? And this prompt will be fed into the Bedrock API or the Claude API, and that will return you the chapters, right? And the crux of constructing the prompt is that you mention or give some context that this is my input, this is my output, and this is how I want my output to actually look like, right? And you can also consider the chapters to be logical and semantic breakdowns, where the text is like moving on to the next topic, where these kind of phrases are used, and similar to these phrases as well, right? So since LLMs are trained on a lot of text, it should be able to give you the correct chapters. So now, once this chapter data is given to you, I'll write this. Okay. So once it comes to us, what we need to do is that we need to store the chapters. Okay. You need to store the chapters into the S3, right? And this is our final result, to be honest, right? So this is our final result. And at every moment, the S3 used, as I told you, you can use the bucket name, right? And the path should have a video ID folder creator. So it should be created, right? There should be a video ID folder. And in that, these results are being stored to correspond that what is like, we are not conflicting, right, between multiple requests. Secondly, what we can do over here is that so let's visualize like if there are 100 clients trying to use this system, right? This Lambda is managed automatically by Amazon, right? So we don't need to worry over there. Secondly, this entire so this glue job, let's say even if one processing is happening, one download is happening for another request, another glue job will run, right? So it's a very scalable way of doing things over here. So you can configure a lot of things over the AWS glue, how many concurrent execution it can handle and stuff. I'm not going into the details, but I hope this triggers a curiosity in you to go and learn about this individual components and how Lambda, glues, S3 and API gateway are being used over here, right? So even they say Amazon Transcribe service. So this is just an idea, right? I'm not sure how even YouTube does some in automatic chapter creation right now, but I'm not sure how it's done over there. And this is just taking idea and putting it over here, right? I hope you like the video. And for more stuff like this, please subscribe Saurabh Singh Diaries and let me know if you want the entire code for this running and working, right? Till then, Happy New Year, right? And have a great, fun year ahead, right? And learn and grow, right? Bye bye.